All right, guys, today our title is partial fractions, also known as a bigger title, partial fraction decomposition. And I like the title decomposition because that's what we're going to do. We're going to decompose a big fraction into many smaller ones. And it's a calculus skill, so it's good. All right, so basically instead of adding or subtracting fractions into a single fraction, we're going to do the opposite. We're going to go backwards and take a single fraction and break it up into addition and subtraction. Okay, and there's some calculus uses for this, and that's why we're doing it. There are 4 cases, and I'm going to show you 2 today, and we're going to show you 2 tomorrow, and then that's it. First case, case 1. The denominator is a product of distinct linear factors. So if you have a denominator that you begin with that has linear factors, okay, no matter how many, what we're going to do is we're going to put a variable on top of one, another variable on top of another variable on top of another, in order to split it up. This is one day where reading charts or info like this isn't as helpful as just seeing an example. So I'm going to show you one example of exactly what I'm talking about here on the next slide. All right, this says find the partial fraction decomposition of 5x plus 7 over x cubed plus 2x squared minus x minus 2. Now what we're going to do is we're going to try to break that up into a few pieces. And the first thing you need to do when you start this process is you need to factor the bottom, as far as you possibly can. So let's take the denominator here and let's factor by grouping because there are 4 terms. Take out a -1. That's also x plus 2. So I'm going to end up with an x squared minus 1 and an x plus 2 now. And x squared minus 1 is really x plus 1, x minus 1. So here's what I get when I break that denominator up. I get 5x plus 7 over x plus 1 times x minus 1 times x plus 2. Now here's how the partial fraction decomposition is going to work. I'm going to take the first factor of the denominator, the x plus 1, and I'm going to put an a on top of it, just a big A. I'm going to take the second factor, which was x minus 1, and put a big B over it. I'm going to take the third factor, the x plus 2, and put a big C over it. All right? And I'm just going to work this thing out. I'm going to try to combine the fractions on the right now, and you'll see why in just a second why this is going to work. So I'm trying to move this for you. Okay. So what I'm going to do is I'm going to multiply everything by the LCD. I'm trying to change colors here. That is the LCD. So multiply the left-hand side, the fraction just goes away. The right-hand side, it leaves me a times the x minus 1 times the x plus 2. It's going to leave me a b times the x plus 1 times x plus 2. I'm not sure why that's moving. And then the c is going to be really x squared minus 1 because that leaves an x plus 1, x minus 1. All right, so I'm going to multiply this stuff out real quick. So I get 5x plus 7. I'm going to go do a couple things at once here. I'm going to multiply the a through and do the FOIL here. So if I do that, I get ax squared plus ax minus 2a. Do the same thing here. Do the FOIL plus do the b. So I got bx squared plus 3bx plus 2b. Having a hard time multiplying here. And we're going to have cx squared minus c. Right now, what I'm going to do next is I'm going to group the things that I can. I'm going to combine my squares. I have 3 squareds here. So I'm going to pull out the x squared. And I'm going to put a plus b plus c because that'd be the coefficient on the x squared if I combine them all. Now look at the x's. Let me change colors to make it easier to see. There's an x. There's an x. That's all the x's. So if I factor out the x, the coefficient would be a plus 3b. Let me change colors one more time. And we're going to do the constant term. There's a constant term, there's a constant term, there's a constant term. So if I group them together, my constant term would be be negative 2a. So looking at the x's again. Negative 2a plus 2b minus c. All right, now, here's where the magic happens. Like how I said that, it's all magic. Okay, so notice there's no x squared term on the left-hand side, which means there can be no, because it's equals, there could be no x squared term on the right-hand side, which tells me that the coefficient in front of the x squared must equal 0, like it has to. The coefficient in front of the x, because there's 5 x's over there, that a plus 3b has to equal 5, like it has to, because that's the coefficient on the x over there, and they're equal. The 7 is constant, which means the constant term over here, the negative 2a plus 2b minus c has to equal 7 because that's what it is on the left-hand side, and it's equals. All right, so to save time on the video, I'm going to go ahead and just solve the system on this somewhere else and come back and show the answer. So Okay, just did that, and here's what I'm finding. I'm finding out that my A is 2, and my B is -1, and my C is -1. And we'll work on solving these things. We've solved systems the whole chapter anyway. You should be great at that by now. So that's not the answer, though. The answer is your fraction broken down. So look back here where we started, even though I've kind of messed it up there. Let me see if I can move that a little bit. But we started with the A on top of the x plus 1, the B above the x minus 1, and the C above the x plus 2. Okay, so I'm just going to put them back in there for my answer. So I got 2 over x plus 1 plus -1 over x minus 1 plus -1 over x plus 2. And here's what would happen. If you did go through and add all those fractions together, you would end up right back where we started. So not much to it. I'm being sarcastic. There's a lot to it. But that's what partial fraction decomposition looks like. I'm going to show you one more here. All right, and this is case 2. All right, in case 2, so the denominators are a product of linear factors, some of which are repeated. So if you have a product that's repeated, you have to build up to it on your denominator until you get to the whatever exponent is on that factor. And again, this is kind of hard to explain without just reading, the rule or whatever. So I'm going to show you one more example, and hopefully it makes a little bit of sense, hopefully more than the last one did. All right, here goes. Find the partial fraction decomposition of x squared plus 1 over x and x minus 1 cubed. Okay, the good thing is the denominator is already factored, so this is going to look crazy when you first see this, but here's how you have to work this kind to decompose this thing. So what I'm going to do is I'm going to put an A over the x. I'm going to put a B over the x minus 1. Here's where it gets a little crazy. I'm going to put a C over the x minus 1 squared and a D over the x minus 1 cubed. And yes, you do have to do every bit of that. You have to build up to your biggest exponent. That's some terrible handwriting right there. Sorry about that. Let me fix it real quick. It should be x minus 1 to the third power. Okay, and on this one, just like the last one, I'm going to multiply by the LCD, which is this, by the way, which is that main denominator. On my left-hand side, it will leave an x squared plus 1. On the right-hand side, it will leave me an A times x minus 1 cubed. It would leave me a B times the x and x minus 1 squared. That's a lot. The C would need the x, and one more x minus 1, and the D would just need the x. Okay, so that's just multiplying through by the LCD right there. And here we go again. I've got to multiply that stuff out and see what happens. So I still have the x squared plus 1 on this side. Over here, again, I'm going to cube the x minus 1, and I'm also going to put the a with it. So I get a x cubed minus 3a x squared plus 3ax, and then minus 3a. Sorry, just a, not 3a there. Remember, it goes 1, 3, 3, 1. This one, same deal. I would have bx square multiply double square times bx would be bx cubed. I would have negative 2x when I double it, so I'm going to get negative 2bx squared. Then I have a plus 1 times bx, which is bx. Now I'm taking the c through. I'm going to have cx squared minus cx, and I've got the dx at the end. Man, that's a lot of stuff. Is this fun or what? You got to love this. Okay, so I'm going to group my stuff. There's an x cubed, there's an x cubed. So I have the x cubed. I would have an a plus b as a coefficient. I'm looking for my x squareds now. So there's an x squared, there's an x squared, there's an x squared. So if I pull out the x squared, my coefficient would be negative 3a minus 2b plus c. I'm looking for my x's. About to run out of colors here. There's an x, there's an x, there's a bunch of x's. All right, so if I pull out the x, that's going to leave 3a plus b minus c plus d. That's a lot. And then I'm looking for a constant term. Let's see what I find. Constant term-wise, I'm seeing a negative a, and that's all. So I'm going to put a minus a at the end. All right. Okay, so, and this still equals, of course, x squared plus 1. All right, so what I know from what I'm looking at here, I know that there's no x cubed on the left-hand side, which tells me a plus b right here has to equal 0. My second coefficient, my negative 3a minus 2b plus c has to equal 1 because there's 1x squared on the left-hand side. My next one, the 3a, it's supposed to be an a, plus b minus c plus d has to equal 0 because there's no x on that side. I need to squeeze this up a little bit. And the last thing I know is that negative a has to equal 1 because that's the only constant over there. Now, knowing that, I know what a is already. A is going to be negative 1. And if I know that, because the first equation says a plus b is 0, I know b is positive 1. I can plug them both in that equation right there, and it's going to tell me that c is going to be 0. And then I can plug all three of them in here, and it's going to tell me that d is going to equal 2. Now, those are important, very important, but again, they're not the answer. You're going to have to come up here. Notice where we started. Look where we started right here. I'm going to circle this in white real quick. That's where we started. So I'm going to take my A and put it here, my B there, my C there, and my D there. All right, here it goes. I'm going to pull this up a little bit so I can write my answer. Don't forget to write your answer. It's kind of the important thing. So here I go. Negative 1 over the x. 1 over x minus 1. There's no need to put a 0 right there where the c is because 0 over anything is just 0. D is 2, so I'm going to go 2 over x minus 1 cubed. And there you have it. Piece of cake. Not really, but after we do some of these in class, you're going to be fine. I promise you. Just got to hang in there a little bit. I'm not saying it's easy, but you know, you can do it. It's just systems once you get past the second and third step. And we'll work on it. See you then.